Hi everyone, my name is Andrew and I'm an AI engineer on the Multimodal AI team at Educational Testing Service. Our team aims to leverage multimodal data to provide actionable feedback and insight to users who are seeking to improve their soft skills. A large effort at ETS is underway to measure and assess 21st century skills in learners of all ages. So these skills are often called transferable skills, and they're critical for success in the workplace and in life. So examples of these include things like leadership, creativity, digital literacy, and much more. The work that I'll present today looks at confidence in communication. So confidence, much like other parts of communication, is multifaceted, meaning a combination of both verbal and nonverbal cues play a large part, leading us to model these characteristics using multimodal data. A key question that we then ask is, how can we help learners enhance this soft skill? Our approach is to build a system that allows users to practice their speaking skills and to be given feedback about their performance. So this work targets a piece of that practice system. Specifically, we're predicting how confident a speaker appears in a video recording. We leverage both the visual and the audio components of the video to make this prediction. To achieve the ground truth labels of confidence, we collaborated with behavioral scientists at ETS to create a confidence rubric. A low confidence speaker might be more hesitant and appear uncomfortable with their movements, even perhaps with low eye contact. A more confident speaker, on the other hand, might be more comfortable with their posture and facial expressions with smooth speaking patterns. So we leveraged the data set of 1,891 videos that ETS had collected in 2017. The videos were collected as part of a study where a total of 223 participants recorded themselves responding to a textual prompt in an asynchronous video interview setting. Participants could respond to up to 8 total prompts, such as explain how you dealt with the situation where you experienced a conflict with your colleagues. So each video was total of 2 minutes in length, and the data set and the original task of modeling hireability was published at Arti in 2017, and our team has published other applications using the data set as well. Using the rubric that we designed, we partnered with Scale AI, which is a data annotation company, to conduct annotations of the 2-minute videos. A total of 233 videos were labeled with either low, medium, or high confidence. 10 annotations were given for each video, and Scale provides a final aggregated label for each video. The distribution of these annotations is shown here, where the majority of the 233 videos were medium confidence, with roughly 20% labeled as either low or high confidence. In addition to the confidence ratings, videos were also labeled in-house for their perceived demographics. 5 annotations were provided for each video to label the speaker's perceived gender, race, age, and accent. Of course, while these attributes are certainly not binary, in reality, we binarized the labels to be more conducive for bias mitigation algorithms that I'll discuss. So using the labeled data, we then compared the performance of models that were bias mitigated to models that were unmitigated. We used the FairLearn open source library for bias mitigation. We chose the exponentiated gradient optimization algorithm, which enabled us to use multi-class outputs. Additionally, we used the bounded group loss constraint, which aims to ensure that each group, which would be each binary demographic group, is under a preset upper bound value. For the loss function, we chose the mean absolute loss, which in this case is only possible in this setting because it is a ranked order classification problem, and we limited our options of upper bound values to 0.25 and 0.5 based on early experimental results. For all of the experiments that we conducted, we trained an XGBoost classifier with pre-selected hyperparameters, and we trained with multimodal features extracted from these videos. The model performance was derived from a variation of 10-fold stratified cross-validation, and we measured the performance by accuracy and F1 score. We conducted 5 total sets of experiments comparing the binary groups of perceived gender, race, age, accent, and finally gender intersected with race. All features, modeling details, and bias mitigation algorithms can be found more in detail in the paper. So I would like to highlight one set of results from our experiments, the results from the gender intersected with race. In real settings, each demographic characteristic does not exist in a vacuum, but rather as part of a set of attributes. As such, we've begun to deploy models that mitigate biases for intersections of demographics. This typically requires large amounts of data to overcome the few data points per subpopulation, so we've limited it to 2 demographic variables to start, perceived race and gender. We found that both upper bound values produced accuracy and F1 score improvements over the unmitigated baselines. A highlight from these results is that both groups of perceived females, both white and non-white females, yielded significantly improved prediction results in terms of both accuracy and F1 scores. While still not reaching the level of predictive performance of the male groups, each percentage point improvement has a real impact. For subpopulations that are more susceptible to machine learning errors in the literature, every opportunity for improving model performance should be taken. For the remaining sets of results, please see our full paper. We found that each demographic split saw improved predictions when mitigation was applied. The overall goal of this work is to eventually provide actionable, informative feedback to users, which is first enabled by the accurate prediction of their levels of perceived competence. A critical component of this is to leverage a large data set of labeled videos, where the labels are created in a standardized, robust fashion. Human evaluation of competence is highly subjective, and we've crowdsourced this task with larger sets of videos where each video requires an agreement of many annotators before being finalized. Perceived competence is, of course, a multifaceted construct, opening the door for more investigation in leveraging the synergies of multimodal data. We believe in the robust creation of rubrics with careful annotation schemes as a required step for modeling transferable skills. Thank you, and I'm happy to answer any questions.